Let's graph an exponential function using transformation, and let's include a vertical stretch. Man, things are getting exciting. So we're going to graph f of x equals 2 times 3 to the x minus 4. So a lot of this is like what's all happening. So you can see we have this piece out front, and we have this minus 4 on the back. Those are all extras, right? So it's oftentimes that we want to focus on just the parent function. Let's just focus on f of x equals 3 to the x. Because if I can get a visual for the parent function, then everything else is just a little bit easier. Okay, so let's start there. Let's think about what this all means. So if I pick a couple of points, I'm just going to pick -1, 0, and 1 for my x values because those are small and easy to work with. So that's going to give me 3 to the negative first. Well, that's 1/3. 3 to the 0 is just 1, and 3 to the first is 3. So I have given myself 3 ordered pairs to graph for my parent function. Now, I want to point out now that inside this whole piece up here, the 2 is being multiplied by 3 to the x. So this y column is essentially the value of 3 to the x when I've plugged in a specific value for x. So if I take x to the negative first, as I did, right? I took 3 to the -1, then what happens if I multiply that by 2, right? So we are simply multiplying y by 2, right? So this is kind of our next step. We're doing this piece right here. We're basically stretching it by a factor of 2. So 1/3 times 2 is 2/3. 1 times 2 is 2, and 3 times 2 is 6. So I now have 3 ordered pairs: -1, 2/3, 0, 2, and 1, 6. This is what I want to start with. I know I still have a -4. I haven't forgotten it. But I want to start by graphing these 3 points. Okay, so again, I've got -1, 2/3, 0, 2, and 1, 6. So let's do that. -1, 2/3, 0, 2, and 1, 6, which is just almost off the screen. Okay, so this right here, these blue dots, let's just give myself kind of a graph here. These dotted blue graph is f of x equals 2 times 3 to the x. But remember, we still have this -4. So what does, if I've got f to the x equals 2 times 3x minus 4, what does this -4 outside tell us to do? It tells us to move everything down 4. So what I'm going to do is I'm going to take those 3 points and I'm simply going to move them down 4 units. So 1, 2, 3, 4. This is where the new spot goes. Everyone moves down 4. 1, 2, 3, 4. 1, 2, 3, 4. And recall that the initial parent function has a horizontal asymptote at y equals 0. So I will also move that down 4, and my horizontal asymptote becomes down here at y equals -4. So let's get rid of this one. Okay, now I am ready to connect my dots. So if I do that, I guess I could have done that in a solid line. But this is our new exponential graph with a transformation, vertical stretch. So you can see how, because it's being multiplied by 2, it gets kind of elongated a little bit. But that is graphing an exponential function using transformations, including a vertical stretch.